Hello friends, welcome to eTutros. Today we are studying vectors. So before studying vectors, we should define what a vector is. So you have already studied in your first standard a mathematical numerical number like 5, 10. When you say only 5, it is just a magnitude. It doesn't say which direction. So here how the vector is different from scalar quantities. Vector is a quantity that has both magnitude and direction. This is important. Vector has direction as well as magnitude. I will show you some of the vectors. Like these all arrows are a representation of the vectors. Like for a scalar quantities, only the magnitude is sufficient. If the magnitude is 5, one quantity is a magnitude 5, then other is quantity also has a magnitude 5, then we said these two scalar quantities are equal. But this isn't a case with vector. For a vector we need to be both direction and magnitude as well as are equal. Here you can see example. For example, you can take this vector and this vector. These both vectors have the same magnitude but different direction, so they aren't equal. Now take this vector and this vector. These two vectors have the same direction, but they haven't the same magnitude, so they aren't equal. But this, what about this one and this one? They have the same direction, same magnitude, so they are equal. So for a vector to be equal, both direction and magnitude should be equal. Now we will study about the representation of the vector. So vector is represented by 2 points, an initial point, a terminal point. A direction of vector is from initial point to a terminal point, as represented by PQ, where P is an initial point and Q is a terminal point. And this length of an arrow is on a scale of the magnitude of vector, and this arrow represents its direction. So this PQ has a both magnitude equal to its proportional to its length, and arrow indicated direction, so it is a vector. We will represent vector mostly in a coordinate system. Here P has a coordinate x1 y1 and Q has a coordinate x2 y2. And a direction value vector is represented with respect to some axis. This is, suppose this is x-axis of your coordinate system. So the angle, this angle represent the direction of this PQ vector. We will see further how this direction of angle is converted into vector form. How to find the magnitude of a vector? We can apply distance formula to find between point P and Q to find the magnitude of the vector. And for a direction you have given this angle. Now to get a vector we have to subtract the initial terminal point from initial point. But vector has a very special property that it can be taken anywhere in a space with keeping its direction and magnitude same. Like this vector is here, I can move this vector here, but I have to keep it direction and magnitude same. It isn't a problem. So for this EV convenience, we always take an initial point to be origin. This is just for ease of the calculation. Okay, so P is taken as origin and Q is a terminal point whose coordinate is some xy. Now the vectors aren't added like a scalar. The vector addition has follow some different principles and different rules. So we are gonna see how we gonna add. Suppose we have two vectors, vector v and vector w. So now we are learning addition of two vectors. So suppose like I have already mentioned, we have two vectors here, v and w. So what we have to do to adding two vectors, we have to move vector w in such a way that it is coinciding with the final point of a vector w is coinciding with the terminal point of vector v. And now this red vector gives the resultant of vector v plus w. So for addition of two vectors, you have to arrange a vector in this form such that uh, initial point of one vector coincides with the terminal point of another, and the resultant is when we join the initial point and this final point. This is a resultant vector represented by the red arrow. I hope you get it. Similarly, this is a very important, like for example, if you are given a vector v and you have to find a vector minus v, you just have to reverse the direction keeping the magnitude same. For example, you can see like this is vector v and this is another vector minus v. They have the same magnitude but they are totally opposite in direction. So this is what mean of a negative vector. Now we will see what will happen to vector when we multiply it with some scalar quantity. When we multiply a vector with a scalar quantity, like here we multiplied by 3, its direction it doesn't changes. It just increase in a magnitude by the amount equal to that scalar quantity. For instance, here we multiply this vector v by 3 and we see what will happen to that. It become 3 times in magnitude and direction of these v and 3v remain same. Only difference is in magnitude. This vector magnitude is 3 times of this vector. So this is a fact of multiplying scalar to a vector. In further videos, we will perform further more operations on vectors. Thanks for watching. Happy learning.